everyone for being here. We're excited to share our technology today, and we'll talk about different kind of wave mitigation and also habitat creation. Our background is in 3D printing construction. We've started off on the real estate side, and now we are now on the infrastructure side, looking to support DoD, DOT, DOE, and also lots of habitat creation and different kind of grant opportunities. So thank you for having us.
Thank you. So we will talk a little bit about what we're doing, the SEAHIVE technology, where it is at the moment, our progress in producing those units, and we will show a little bit from our production and how we use the 3D print technology to build those modules. Can you guys see my screen right now?
Yes, it looks great.
Okay, great. So we are here to talk about 3D printed green gray coastal resilient coastline protection. We are working with the SEAHIVE technology from University of Miami. Just see here. So the reason why we, or something that came out actually last week caught our interest, and we decided to talk a little bit more about this today. We are privately funded, but we are also funded by SBIR grants. So we got a direct to phase 2 SBIR grant together with University of Miami, Titan Cement, and a company named Carbon Limit that captures carbon into concrete. We have been looking in, or are looking actively into NOAA funding for projects, but it came out this opportunity, or we found this opportunity recently for a phase 1 study where it's award up to $175,000 for 6 months to perform feasibility and proof of concept research. This is why we are here today, to see if we can find any synergies with some of you participants and apply for some of this funding. We can discuss that later in the presentation more in depth. So construction 3D printing is a form of cementous additive manufacturing that is used to fabricate building, houses, and infrastructure components in U shapes. We are a climate tech company based in Broward County, and we develop efficient and sustainable green-gray coastal protection solutions through 3D printing. Our strength is in designing, building standard operating procedures, scale, and the logistics involved with large-scale 3D printers. We will show you more about our printer soon, and also handling the material, develop the material, and produce units. We work within coastal infrastructure. We're also starting with land infrastructure, and we're also in residential. Our customers are local, state, federal government. We also work with a lot of coastal engineering or engineering firms to develop this technology. We work with Jacobs, ACOM, and some coastal engineering firms here. When it comes to the market, you all know that coastal protection is a big problem in United States with the rising sea level and increased strength in hurricane here in Florida, and US is estimated to spend more than $416 billion to build new seawalls and different coastal resiliency efforts before 2040. We are working with University of Miami on something called SEAHIVE technology. This is a product developed under a grant from DOT that later become a part of REFENS. REFENS is a DARPA-funded grant that UM has been working under for the last couple of years. So the product is a wave energy dissipating product. So think about it as speed bump under the water that breaks down the wave in those holes and dissipate that energy. So when the water hits the shore, the waves are lower and less impactful, and that protects the coast. Those are for the near shore or offshore units, and we're also working with near shore units that you can see in the right corner here, which you can put in front of the seawalls to protect or break down the wave before they hit the seawall. We will come to our production methodology and how cost efficient and durable the products are, but why we're here today is looking more into the habitat creation and restoration. Here are the two first pilots that has been done in by University of Miami. First pilot is at South Beach, which is an offshore unit, a small assembly, and a little bit larger assembly near shore in Pompano Beach, Wahoo Bay. So on the left side, they are seeing more marine life are coming, and they're planting corals to, and in the right side there in Pompano Beach, they are planting mangroves in that little cavity there. And the theory there is that the mangroves should attach to the SEAHIVE and creating a green-gray structure long term. So the green, when we talk about the green and the gray is the concrete, the marine gray concrete. The gray is the mangroves, the corals, the oyster habits, the carbon capture technology. And down the line, we're working with some interesting projects with National Renewable Energy Lab when it comes to capturing wave energy. We have here, you can see some photos from our production. This is a small assembly of North Bay Village. And you can also see here in that we are experiment in the bottom corner. We started off doing those as single units as they are now when they're precasted.
What?
But
all right, kid is in here with me.
oh, sorry, someone is speaking. But in the top, you can see that we are making assemblies of those, and these are our method of production. We can create larger cluster of those units, and with a larger cluster, we can make the production more efficient and safe, and also the transport and deployment more safe by making larger units instead of putting them into the water one by one. This is a production we're actually doing now as we speak. This is a real project for our artificial reef for Okaloosa County. Those are larger type modules. They're around 15 feet and I think 8 feet height, and are going to be deployed hopefully already this year. I'm gonna go over also some photos so you can see if you're not familiar with 3D printing. We want to show you how it's looking in real life. Some of the photos here are tests that we have conducted at the Sustain Lab down at University of Miami. They have a Category 5 wave and wind tank that those products are being tested. Here we can see Professor Landolf, who is one of the inventors behind the SEAHIVE system. There are some pictures from our first production where we did those in single units. Here you can see we start exploring methods to use the cluster printing. Here you can see how our reinforcement is working. We work with only non-corrosive material. So here you can see a glass fiber rebar being printed over. We use different kind of textures. This is something we are interested in exploring more. We can do after work on our products to create those different kind of textures that is optimal for the local marine environment. Working with all the tests on the material side, which is testing the carbon capture, potential in our material with the carbon capture technology from a company named Carbon Limit. So the theory is that it stores permanently more carbon and also deeper penetration of the carbon into our products. This is currently being conducted tests to quantify this material. Our material is marine grade, so we're following Army Corps of Engineers marine grade requirements. And as I said, we work very close with Titan Cement. Titan Cement is one of the most sustainable concrete companies in the world. Here you can see some pictures from our modeling. This is how it looks when we are putting it into the computer software. There is a photo from University of Miami that is from the South Beach deployment, and you can see already after a couple of months they are fishes swimming around, and it creates habitat. You see those kind of locks here. This is where they're going to plant in corals into those structures. We have a zero waste. Jump this one. Every leftover product we have, we reuse in our cavities after we have been printing. We solid fill our cavities. So we are striving towards to be zero waste on our concrete. Doesn't seem to. So here you can see how the printer is working when we're doing those larger scale modules. Our printer is from a Danish company that make the gantry style printer, but we're also exploring working with other type of printers that are on the market, and we want to stay ahead on both the best printers and the best material solutions. Here we have some of the finished products from our first production run. Those we are producing now at the rate of 2 a day, and the production will finish here within 2.5 weeks. And they are going up to Calusa County and being deployed in the water, hopefully before New Year.
Go ahead.
Yeah.
People's comment.
Here. So here are more of the finished products. We're moving them out. We are training how to move those out in an efficient way. These are some other R&D projects that we're conducting currently, and some more videos. Yes. Okay, so this is our R&D that we're conducting, and we can see now when we're working with more coastal engineering firm that and offering our products and services to also develop more products. Maybe Adam, you can take that a little bit about the technical part with CAD drawings and how models can be developed very, very quickly.
Sure. Yeah. So when we talk about additive manufacturing, it's been around for many years in more of the aerospace or medical or manufacturing areas, and the value is still the same here when we talk about coastal protection. You want custom, you want pieces that fit what is needed for the requirements, whether it's environmental or it's some kind of spatial or mechanical need. Traditionally, as you know, precast or dry cast or these other technologies, you need to invest in a heavy mold and you're kind of stuck and you can't change, you can't deviate from that mold without spending tens of thousands of dollars. What we're able to do is simply go into our CAD system, design. We do have many different cases where we've had to make a change 5 minutes before a print. Per the customer's need or per some kind of tweak in the engineering need for that R&D, and we're able to make those changes and go ahead with their print. So what this allows us to do is it allows us to work with our customers, whether they're coastal protection firms, whether it's the Department of Defense, U.S. Army Corps of Engineers, We are part of Engineering with Nature, which is a U.S. Army Corps of Engineers initiative. And we are looking to provide lots of value to our customers, whether, like I said, it's a coastal protection or a coastal engineering firm, or directly to the government if there is a need. So we are very confident in our flexibility and our scale. And the reason we're also here today, part of our green division, we work with a lot of coral groups, we work with mangrove groups, but we want to definitely, we know that the benefit of oysters, and oysters are, as we know, they're not just a South Florida a solution like corals are. Oysters are all over the country and the world. So we definitely want to support as many people as we can. We are very scalable. We are well funded. We would like to open up different factories in different areas of the country, not just South Florida. So as far as design goes, we're here to work with you, and we're here to do what we can to fit what that coastal need is to support the oysters.
All right, thank you so much, Adam. I'm going to continue down the slide here and show some of our products or renderings that we're working on. Here you can see our offshore solution. This is for a customer that we are working with. It's a wide assembly. This is almost 30 feet wide, so it is a big product. Here you can see the nearshore. This is a similar product as on Wahoo Bay, but as you can see, they are all printed in one piece, which make the deployment, we believe, up to between 5 to 10 times faster. And speed is also of importance when it comes to producing. We can produce quick, we can prototype quick, and we can also deploy quick. If the project is big enough, we can even move the machine or a smaller type of machine really close to the place on a flatbed, on the back of a flatbed. Those are called robotic arm printers and can be printed on site and put directly into the water. Here is another product we're working with the SEAHIVE technology, and we can print a bench and other kind of products that we have under development. This we're exploring with a breakwater or a jetty, some dredge material stabilization units, and this is for the future that we're looking into oscillating water column that will basically drive a turbine and can store energy into a battery or being put into the grid. These solutions are growing more and more, and they're not ready for ripe yet, but we want to be in the front end and see how we can generate wave energy. The last part is, of course, the deployment that can be complicated. If it's smaller unit, you need divers. Divers is very risky and not very cost efficient, and it takes a long time. We want to automate those deployment processes to be able to not have divers, but being able to easily navigate those units in straight row under the water. So circling back here to our opening here, we are not expert in the green. We are learning as we go, and we learned a lot about corals. We start learning about mangroves, but what we're looking for now is to find a collaboration between the experts within this industry and look into if we can find a way where we can apply for a grant to start looking into what is the optimal structure, what is the optimal design for oysters that can maybe be combined with wave breaking or with wave dissipating, or create other habitats for fish or mangroves, or can we make combination products? So what kind of design can we do that is cost efficient and that can be easy to scale? That is number one. Number two is what kind of material. We can do all the material testing together with the University of Miami and Titan Cement to make the optimal material for oysters to grow on the material, or if there is a surface texture, and that comes to the shape of the surface. With 3D printing, we can create almost any shape. We can create small holes. We can create a rough surface. We can create a flat surface. What are those best optimal habitats for oysters? So we just wanted to, here with this meeting, present what we do and feel out the interest from you, the experts within the field, and see if we can create a collaborative effort here. So that
just wanted to put in there, thank you again for TNC for including us in this talk today. So thank you to our friends.
Yes, thank you. With this, I leave the word open for questions, or maybe Katie, if you want to take over.
Certainly. Thank you, Fredrik and Adam, for that presentation.